Good morning, everybody. This is a wonderful turnout on the Monday on the week of the 4th of July, and I'm very pleased to see you because I know you'll be well rewarded. I'm Nancy Gwynn. I'm the director of the Smithsonian Institution Libraries, and it's my great pleasure to start off our 2009 series of speakers who are co-sponsored with the libraries by the Smithsonian Institution Archives and the Office of the Chief Information Officer. So I thank them both for their help with our series. Since 1997, Dr. William Noel, or Will to his friends, has been Curator of Manuscripts and Rare Books at the Walters Art Museum. After receiving his PhD in 1993 from Cambridge University, he's held positions at Downing College at Cambridge and at the J. Paul Getty Museum. He's a well-regarded published scholar, and he teaches at the Rare Book School at the University of Virginia and in the Art History Department of Johns Hopkins. But it's his journey since 1999 when he began to direct an international program to conserve, image, and study the Archimedes Palimpsest that is of interest to us this morning. Actually, I think the journey started before 1999. The Palimpsest is the unique source for three of Archimedes' treatises. Archimedes, the Greek scientist called the greatest mathematician of all time, who lived from around 287 to 212 BC and was at the same time an astronomer, a physicist, and an inventor. Dr. Noel's journey is recounted with co-author Raviel Netz in a 2007 book titled The Archimedes Codex: How a Medieval Prayer Book is Revealing the True Genius of Antiquity's Greatest Scientist. Some of the reviewers call the book Ancient Math for the Math Non-Lovers, interdisciplinary and fascinating, an engaging and intriguing account of science and scholarship, and a splendid story, splendidly told. So here to tell us that story is Will Noel. Please join me in welcoming him.
Thank you, Nancy. Thank you very much, everybody. It's a great pleasure to be here. And it has been a 10-year journey now, so each time I tell the story, it gets a bit longer, and I now have to go through it at lightning speed. So get ready. I am going to talk about the thing on the right. And I'm not sure. Can we dim the overheads a tiny bit? I will delegate that responsibility. Here's Archimedes about to get it in the net for thinking about circles instead of saving his soul in Syracuse in Sicily in the 3rd century BC. An astonishing man, but all that we really know about what he wrote, we know about from just 3 books. Rather boringly called Codices A, B, and C. Codex A was lost by an Italian humanist in 1564. Codex B was last heard of in the Pope's Library in Viterbo, north of Rome, about 100 miles north of Rome, in 1113. And that's Codex C on the right, and it landed on my desk in 1997. And it is the unique source for on-floating bodies in the original Greek, the only place in the world where you can find Archimedes' method of mechanical theorems, the only place in the world where you can find his treatise, the Stomachia. It was made in Constantinople in the 10th century, and rather wonderfully, Isidore of Miletus, who was one of the 2 architects of Hagia Sophia in 537, was very important in the transmission of Archimedes' works. And one of the things about the transmission of Archimedes' works is that very often the people who saved him were the people that applied him and used him. And one of the things about Archimedes that makes him so different from Euclid is that the manuscript edition of Archimedes is so very thin. When you think about ancient texts surviving until 1455, you've got to think of it as a race. The good guys are the scribes, copying and copying and copying and copying, and the bad guys are the destructors, and they're destroying and they're destroying and they're destroying and they're destroying. And Archimedes lives absolutely in the twilight zone, and he still does. Euclid made it reasonably easily because he made it into the Christian curriculum. But Isidore is one of those fundamentally good people whom we need to thank for the fact that we have Archimedes' treatise today at all. In the 13th century, something that was standard procedure in the Byzantine world happened to this manuscript. The book was taken apart. All the text was scraped off. Orange juice, knives. If you imagine medieval manuscripts made as newspapers, so you take them apart, then you cut them down the centerfold, and you stack them in a corner. And you don't just do this for the Archimedes manuscript, you do it for 7 manuscripts, because you want to make a bigger book than all the parchment that Archimedes could use. So you have 7 leaves from 7 manuscripts with all the text straight off, strapped in a corner, and then you write text at 90 degrees to the old text. And you write a prayer book and you rebind it, so you have a book that's that's half the size in terms of height as the old manuscript, but twice as thick. And that's what happened to Archimedes in the 13th century. And from then on floating bodies in Greek and the method of mechanical theorems and the Stomachion was buried beneath Christian prayers. That's what the Archimedes manuscript looks like now. It's the only beautiful picture I've ever seen of the Archimedes manuscript. Palimpsests aren't very pretty, but this one is nicely lit and out of focus. The manuscript eventually made it to the monastery of St. Sabas, and it was at the monastery of St. Sabas, about 8 miles east of Bethlehem, in the Judean desert, from at least the 15th century to the 19th. And we know that because when it was catalogued in 1899, there was an ex libris inscription in the book that said it was from the great laver of St. Sabas. Such has been the mutilation of the book in the 20th century, as we'll see, that ex libris is no longer there. So we must thank that 1899 cataloguer. The catalogue was done here at the Metochion of the Monastery of the Holy Sepulchre in Constantinople. It's a small Greek Orthodox community in Istanbul. And we know it was there by 1846 because one of those legendary people, Constantine Tischendorf, wrote about his travels in the Orient in 1846. And he says that he found nothing of particular interest in this monastery except a palimpsest containing mathematics. And that's all he tells us. But one leaf from the Archimedes Palimpsest is now in Cambridge University Library, and it was given to Cambridge University Library by the heirs of Tischendorf's estate. So he obviously filched a leaf from the book there. The manuscript was discovered as a result of its cataloguing in 1899. It was catalogued by Papadopoulos Kerameus, who didn't have tenure, so he was paid by the page for his work, so he decided to translate a bit of the undertext as well. And this was Greek mathematics that he couldn't identify. But Johann Ludwig Heiberg in Copenhagen had already done a critical edition of Archimedes, and he read the catalogue and he said, "This is Archimedes, and I've not seen it before." And he went to Constantinople in 1906 and discovered something truly miraculous, which is two whole new treatises by Archimedes and on floating bodies in the original Greek. He was a professor. He did most of his work over the summer vacation, and he also took photographs of the Archimedes Palimpsest, which were lost, but we tracked them down in 1998. And so this is a photograph of the book in 1906 when Heiberg found it. And you can just make out some Archimedes text going like that at right angles to the prayer book text. And Heiberg did a wonderful job and did a completely new edition of the works of Archimedes. largely from photographs, which was a phenomenal achievement. He didn't have any of the modern technology that we had today. And his discovery made big news in the New York Times on July the 16th, 1907. You would have thought that a manuscript that had been established as the unique document for one of the founders of the Western scientific tradition would now be safe. It wasn't safe. The First World War happened. Ataturk founded the modern state of Turkey. It was not the Greek Orthodox monks in Constantinople were not in a very good position, so they surreptitiously moved all their manuscripts to the National Library of Athens. A very smart move, and they had to do it very quietly. And when you move manuscripts quietly, funny things happen. And several of the really great manuscripts of the Metochion disappeared. Most of them were beautiful because there was beginning to be the flourishing art market for beautiful books, particularly in America. And lo and behold, Walter's manuscript 526 is a beautiful Byzantine gospel book from the Metochion of the Holy Sepulchre that's now in the collection of Henry Walters. The Archimedes manuscript somehow left the collection at this time as well. And we don't know how. We have made some progress on this. And this is a letter discovered by Georgi Parpulov, who's now at the University of Oxford. But this is a letter from Reginald Bertie Hazelden, who was the curator of manuscripts at the Huntington Library, and he's identifying the Archimedes Palimpsest because a leaf of it's been sent to him, leaf 57. He's identified it for Professor Harold R. Willoughby, who was offered it to sale from a man called Solomon Gerson, who was a book dealer in Paris. So in 1932, the manuscript, even if it fell off the lorry from the Metochion of the Holy Sepulchre, even if it fell off, as an accident, by 1932, it was discovered again and identified and in the hands of Solomon Gerson. Willoughby never bought it. The manuscript came up for auction. It stayed in a French private collection, and it came up for auction on the 28th of October, 1998. And it's open to folio 105, 110. And it's made of parchment, and there you can see the armpit of the goat. I like to think of this as the most important goat in the history of Western mathematics. It actually contains on its back Archimedes' method proposition 14. And it was sold for $2 million to an anonymous private collector. And at the time of its sale, it didn't have many champions. There were 3 people interested in buying it. The Greek government, because Archimedes was Greek. The Greek patriarch, who decided the day before the sale that it had been stolen from one of his libraries. And a private American collector. And a private American collector bought the manuscript and promised to allow scholars access to it. But no one knew who this man was. I actually did manage to find out who this man was, and I wrote him a rather cheeky email saying that I could exhibit it and display it for him. And wasn't it a wonderful thing? And to cut a long story short, he said, fine. And he left it on my desk on January the 19th, 1999. One of the reasons that scholars weren't particularly interested in the manuscript at the time of the sale is that Heiberg was very clever, A. He got out of it nearly everything that needed to be got out. And B, the manuscript is now in such bad condition that we're not going to get anything more out of it. This is a Heiberg photograph of 1906. And you can see an M16 on its side there. It's on its side because Heiberg is reading the photograph like that, because Archimedes' text is like that. And M16 means that it's the 16th page of the method that he came across. This is the same page now. It has a forgery painted over it. And I know that that forgery dates to after 1938 because it contains phthalocyanine green, which is a pigment that only became commercially available in Germany after 1938. This forgery is based on a 1-to-1 scale from reduced black and white images in Henri Aymon's Manuscrit grec de la Bibliothèque Nationale of 1929. At the time of the sale, these forgeries were wrongly blamed on the monks. Not so. The monks don't need to make forgeries. They just don't do it that way. Another thing that happened to the manuscript between its discovery in 1906 and when it arrives on my desk is all the mold damage. This is the unique surviving page of the Archimedes Stomachion as it was seen by Heiberg in 1906, and he's marked ST there. This is the same page today. And you can see that it's been subject to very bad mold attack and with holes in it. Not good news. And however good our imaging techniques are going to be, we're not going to be able to read through that tragic loss. In 1998, this manuscript was a write-off. And here it was at the Walters Art Museum. And that's what it looked like when it arrived on my desk. And since then, I've been working with now a large number of other people to try and do our very best for this book. And all of the work is paid for by the private owner. When the book first arrived on my desk, there was an article in the Washington Post that said, Will Noel has big problem, here is important book. And we got lots of replies saying, we can help you. The one that was really helpful was from Mike Toth, and it went something like, Dear Dr. Noel and Quant, read with interest your article in the Washington Post. It certainly puts our work into perspective. We here at the National Reconnaissance Office might have some equipment that might be able to help. Do get in touch, otherwise good luck with your endeavours. And it turns out that actually the government can't help with the imaging of the Archimedes manuscript because it's a private object and we can't spend American tax dollars on it. But Mike's been volunteering as program manager for the project ever since. And totally invaluable he is too. He's the guy who tells me about cost, schedule, and performance, and there he is relaxing, but most of the time he's drawing up Gantt charts like that with which some of you might be familiar, but I'm not. He just tells me when to go, and I do. The critical path was the conservation. This is Abigail Quant. She's Senior Conservator of Manuscripts and Rare Books at the Walters Art Museum. And the task that fell to her was a tricky one. With the help of the Canadian Conservation Institute, we did lots of research. This is a tiny cross-section through a tiny bit of a diagram, and you can see the remains of the Archimedes ink here. But this is the collagen, and it's breaking down. And now normal parchment manuscripts, those that know them as quite tough things. This isn't tough, this is tissue paper. It's really, really bad. The worst problem is the spine. Now, the Archimedes text runs through the spine of the book. Medieval manuscripts weren't glued together. Gluing is a post-medieval practice. This is hide glue. That's not so bad. This is PVAC. This is Elmer's wood glue to all intents and purposes. It's much tougher than the parchment that it's on. It was done in the 1960s, 1970s. So Abigail had to take that glue apart before we could even begin to image, and to do it without damaging the Archimedes text below. So you will understand that it took her 4 years to take the book apart, and that this is a very rare action shot. Even the manuscripts, even the pages that look reasonably okay are not okay. You backlight them and they look fragile. This is the first page of the book here, and when Abigail took it apart, one of our scholars had an ultraviolet light on it and identified it as a previously unrecognized page of On Floating Bodies in the original Greek. And that was when we realized that we were dealing with something rather extraordinary. This was the first page of the book. It was the first page that was disbound. And with modern technologies, we could get whole new pages that Heiberg hadn't identified, however clever Heiberg was. So Abigail documents everything that she does. Here she's got a mylar sheet on top of one of the pages and is documenting all the damaged areas of the parchment. One of the problems that she faced, or the images faced, was that it was a liturgical manuscript, so it was used in church services from the 15th century to the 19th century. And of course they used dirty wax candles, and imaging through dirty wax is very difficult. So ultimately Abigail had to take off as much of the wax as she possibly could before we imaged it. A whole bunch of detritus, lots of glue, very careful work. The problem with the PVAC is that we couldn't find a solution that really worked to take it apart, so it was a little bit of isopropanol and water, and day after day after day of gentle mechanical getting rid of it. All the fragments, of course, are documented. You can reconstruct the fragments of where all the Archimedes stuff came from, and this became very important because there are 3 leaves missing from the Archimedes manuscript from when it was taken apart in 1906. And from getting rid of the little bits of detritus in the gutter, Abigail realized that those 3 bits, they had pigment in them, and therefore those 3 pages had forgeries on them. And they were cut out from the book and sold and never returned to the book. So somewhere out there are 3 pages of forgeries containing unique Archimedes text on the back. So if you ever see something that looks like a Byzantine forgery, turn it over, see if you've got 2 texts on the back, and I'd love to hear from you. This is Archimedes, this is Abigail taking apart a little strip of parchment that had been stuck onto one of the forged pages. It doesn't actually belong there. It belongs there. That little tab looks like it's a medieval tab. You take it apart, and actually it was cut out from there and put there and just put there to be made to look medieval. All this is 20th century damage. Some of the fragments are tiny. You save all the fragments, you image them with ultraviolet light, you realize some of them have text on, possibly unique Archimedes text, and then you can put them back in place. Conservators know that most of their work is on a scale and on a level that only other conservators truly know. And that's true of Abigail's work on the Archimedes Palimpsest, but here's a rather dramatic one. You can see the Archimedes text here. And we have this problem in the gutter. So Abigail is here unfolding the gutter. And this is a before, and this is an after. And this is a little low-resolution UV JPEG that we sent to Reviel-Net in Stanford, and he circled that and sent back an email saying, this is the earliest symbol of a circle in the history of the Western mathematical tradition. Well, this was a good day. I mean, at this stage in the program, there were lots and lots of bad days. We were just slowly getting to know, just how bad and brutal, well, how bad the condition was and how brutally it had been treated in the 20th century, knowing that it was Archimedes. And our early imaging efforts, as you'll see in a minute, weren't good. If you speak to Abigail now, she'll still tell you that her conservation work on the Archimedes Palimpsest hasn't begun. All she's done is prepared the leaves for imaging. The owner is a patient man. It's been 10 years. You might have thought that he would want to, have his manuscript back before the 22nd century begins. But anyway, here we go. This is a leaf prepared for imaging, and you see it in one of the mats. And now I'm moving on to the imaging part of the story. The story is quite long, and one of the things I should say is that I'm going to talk about the conservation first, and then the imaging, and then the scholarship. But what actually happens is that it's a totally integrated program, largely planned by Mike Toth. And so there's a real feedback loop between the processes of conservation, imaging, and scholarship all the time. And it didn't really matter that it took Abigail 4 years to take the book apart, because during that time we were learning how to image the manuscript. Most of the manuscript was done with multispectral imaging. Bill Christens-Barry from Equipoise Imaging Keith Knox from the Boeing Corporation in Hawaii, and Roger Easton, who's Professor of Imaging Science at RIT. And they've been imaging the manuscript now for approximately 8 years, I think. And it was clear from the start that what they would be doing was using multispectral imaging, light, whatever wavelength, comes at different wavelengths, radio waves, visible light. This is visible light. This is the range of the electromagnetic spectrum that we've been evolved or intelligently designed to receive. But cameras can capture all the way from there up to there, just depending on your camera. So if you see things in different wavelengths of light, you see different things. And the idea of multispectral imaging is that you capture images at different wavelengths of light, and then you stack them together in a data cube, and you have an awful lot of information. And you write algorithms or recipes to bring out the material that you want to bring out. So this is a page of a little detail of the Archimedes Palimpsest. This is in UV light, and you can see the Archimedes text as well as the prayer book text rather easily. This is in infrared light, and you can't really see the Archimedes text at all, which I thought was a bad thing. It's not necessarily a bad thing, as I'll show in a second. The early results looked absolutely spectacular, and I thought we'd cracked it sort of overnight. But as soon as you say something like that to a scholar, they tell you that it's of absolutely no use. And there are 3 reasons for those of you that are interested in multispectral imaging, why this is of no use. Perhaps the most interesting is that the spectral characteristics of the 2 inks are actually very similar. So to get a result like this, it required a lot of processing. And every time you process something, you introduce noise. And noise, when you're imaging a cocoa field in the Amazon rainforest, is not a problem. But when you're trying to read Greek cursive, it is a problem. The other thing is that our whole operation was entirely misconceived. We thought that our job was to get rid of the overtext. Now, if you read 19th century letters, and I'm sure many of you do, reading through overtext isn't a problem. You get used to it very quickly because they wrote letters and they ran out of space and they wrote at 90 degrees, and you can get the hang of it quite quickly. And we don't have to get rid of the overtext at all for the vast majority of what we're doing. We just have to make the undertext come out more. So we've got rid of the overtext here, but in doing so, actually, we just made the process of reading the undertext more complicated, because in reading the undertext, you couldn't tell whether you couldn't see it because of the overtext or because of the parchment. They now look the same. So we thought we were giving people more information, and actually we're giving them less, and we had to really rethink what we were doing. This is an image taken in ultraviolet light, ultraviolet fluorescent light, and you can see an Archimedes diagram here. And you can't see much there. And you can see Archimedes text there, and you can't see much there. There are a few problems with the ultraviolet light. It's a bit soft, and it's monochromatic. There's no color contrast. But what we did, that's what the imaging scientists did, and what Keith Knox did in particular, was to create a blank new digital canvas and pour both these images into them. So if in these 2 images something is light, so here the parchment is light and here the parchment is light, it's going to come out light in the digital canvas. If it's dark, and here the overtext is dark and here the overtext is dark, it's going to come out dark in the new picture. But if it's dark here and light here, it's actually going to come out with a sort of a red tint. And then it looks like that. You can see the diagram more clearly, and you can make a clear difference between the Archimedes text and the overtext underneath it. And sometimes this technique, which is the technique by which we've imaged an awful lot of the Archimedes Palimpsest, is remarkably effective. I've just pulled out a few that show the contrast quite well. We used to image once every 6 months. Abigail would liberate 16 bifolia, and then we would image those 16 bifolia, and we'd come back 16 months later, and we'd get better at it. And then in the summer of 2007, with the Stokes imaging system from Austin, Texas, we re-imaged the entire manuscript in 2 weeks in 16 different wavebands of light, The lights were developed by Bill Christens-Barry from Equipoise Imaging, and they're a wonderful, easy, relatively cheap way to do multispectral imaging, and they're very portable as well. And when you do that, here's the armpit of my goat, 16 different colours. Each of those 16 different colours, by the way, on its own is no use. You have to merge them and write algorithms to bring out what you want. And we have, obviously, what that means is an awful lot of data for those of you that are in the data business, and I'll talk about the data in a minute. So that's what one of our images looks like now. But of course, as a scholar, what you do is you drill in and you drill in and you drill in and you drill in and you drill in until you can just read it. What scholars like to do is to look at images processed in different ways, and particularly it's important with the drawings in the manuscript, and the drawings are the unique source for the drawings that Archimedes did in the sand in Syracuse in the 3rd century BC, and Heiberg didn't pay them much attention. But here you can see a drawing. And it's nice to get an overall shape of the drawing. So if you process the same data in a different way, you can actually bring out the drawing more clearly. So by about 2002, we were producing images that the scholars could read for quite a lot of the Archimedes text. We had a major problem. No optical imaging was ever going to read through the gold ground forgeries. So on April Fool's Day 2004, we had a small conference to try and decide the way forward, what else we were going to do. And we came up with 3 different ideas. One was LED imaging, which we used and which was successful. One was optical character recognition. We had a guy called Derek Valvoorde at the Rochester Institute of Technology who developed a rather good OCR, which actually Reviel Netz did actually find useful in corroborating his readings. But for the forgeries, we found that X-rays were probably the way to go. And so I show you 3 of the people who were at the conference who helped us with the X-rays. One is Bob Morton, who does a lot of work with fossils now. And he works for ConocoPhillips in Bartlesville, Oklahoma. Gene Hall is the professor of chemistry at Rutgers University, does a lot of work on detecting forgeries through XRF analysis of pigments. And Uwe Bergman, who's the staff scientist at the Stanford Linear Accelerator Center, he was doing a lot of work on spinach for the molecular structure of photosynthesis and on the molecular structure of water. And spinach has a lot of iron in it, which becomes rather important because the iron in the palimpsest is iron, the ink in the palimpsest is iron gall. X-rays are just like visible light, but they have a far shorter wavelength and are much more energetic. So instead of interacting with the outer electrons in an atom, which ultimately comes back to your head through your eye as color information, and you interpret it as color information, they interact with the much more energetic electrons on the inner shell of a Bohr atom. So an X-ray comes in, an electron bounces out, and another electron makes a quantum jump from the L shell to the K shell, as it were. Now, what you want to capture is the electron that is the X-ray, is the energy that's now given off by an X-ray that comes back out. So we're not looking at transmitted light. It's not like at the dentist where you get a negative image. We want to capture the electrons that bounce back from the atom. And because atoms have, and what makes an atom is that it has its own structure, its own atomic structure, you can identify the atom that you've hit. So if you can identify the iron atoms on the page and map them, independently of the gold atoms on the page. The idea is that you can make an ion map of your page and you can read the ink on the page. So we tried in a small X-ray machine called the EDAX Eagle probe to identify the pigments in the Archimedes Palimpsest, the atoms in the Archimedes Palimpsest. There's a lot of calcium from the parchment and the way that it was portrayed. There's some chlorine, some sulfur, some copper, some zinc, some magnesium, but there's a nice iron peak. So we think we've got the chance to get some iron. But the trouble is that scanning the iron, scanning on this level, you need to cover a lot of ground with a very, very thin prick of light. So you're going like this across the page with a tiny, tiny light source, and it's going to take you a long time unless you've got a powerful X-ray machine and moving quite quickly. So we needed to go to the Stanford Synchrotron Radiation Laboratory in California. Now, the Stanford Synchrotron Radiation Laboratory is the place that it's a particle accelerator, and so they send electrons around this way and positrons around that way, and somewhere in the middle they smash together and you discover the charm quark and the tau electron. That's not really what we wanted to do with the Archimedes Palimpsest. But now they don't use the synchrotron for that at all, for atom smashing at all. They use it for the energy that the electrons give as they go around the corner, because they're not traveling in a straight line, and they give out synchrotron radiation, and synchrotron radiation is a very, very powerful light source for X-rays. Yes, not valid in Kansas. Use of this device or substance may require, imply, and/or endorse the existence of one or more of the following: chemistry, evolution, electromagnetism, gravity, mathematics, thermodynamics, and education. Duly warned, we thought that Archimedes would be urging us to proceed, and so we did. And here is Abigail placing a leaf of the Archimedes Palimpsest into an XY stage, and the energy comes out through this tube and onto the parchment, and the reflected X-rays get picked up by this detector. And this device, I should say, this experiment was all drawn up and thought through by Uwe Bergman. And 17 hours later, we could read through the gold. I mean, you have to be a nutcase to read it. But if it's unique Archimedes text, the nutcases are out there. They're charming people. They're called Nigel Wilson and Reviel Netz, and we'll meet them in a minute. Here's Nigel, who is at Lincoln College, Oxford. He wrote Scribes and Scholars, Scholars of Byzantium. He's just published the critical edition of Aristophanes, and he is without peer in the transmission of the classical heritage through the Middle Ages to the modern day. Nigel is a very distinguished gentleman, and so I was determined to generate him some very, very powerful images on a computer. So here I am introducing him to a computer. And he's very excited, but actually he just uses photos that we make. We just print outs, which is kind of crazy if you know about images on computer screens, but he does very well with it. He mainly works in the summer when the light's good. This is Reviel Netz, who is much more computer savvy. This is an early attempt to read Archimedes' method proposition 14. So here you have the armpit of my goat. Do you see? Just visible down here. And Reviel is writing what he thinks he can see on the page. And he's guessing down here at this stage. And there's a hole in the parchment just there. And so this here in the margin is a question to Abigail Quant, asking if the tear is possibly original. Because if the tear is original, then of course he doesn't have to put a letter there, because the scribe didn't put a letter there in the 10th century. So he was just trying to get a shape of the landscape of the page at this stage. This was before we developed our pseudo-color. Eventually we developed our pseudo-color, and this is a little detail from that page. And, you know, on occasion you can make the invisible visible. And then on Friday, the April the 13th of 2001, I got this nice email from Reviel. In a couple of months, the first intellectual fruits of our labour will be published, together with a complete transcription of one crucial side of one page, most of which is unknown to modern science. I send you the final lines of the article as it stands in draft form. It is understated. It reads as follows. To sum up, then, the new reading from Archimedes' Indivisibles proof, which is method proposition 14, should call for some reconsideration of the position of Archimedes in some key areas of the history of mathematics, especially the two related conceptual fields of the calculus and of infinity. Now, especially on the webcast audience, hello, I am not standing up here as an expert in Greek mathematics, but what I would say, and I think that this is basically true, is that in the ancient world, everyone knew that the Greeks knew about potential infinity, and Archimedes used it a lot. So you think of a number, and you can always think of a higher number. How high a number? As high as you like, so think of another number. And you can go on, and you can break things down ad infinitum. But they never thought of infinity as the sum of all numbers bang altogether. And they never thought of infinite sets as potentially different. Two different types of infinite sets. And Reviel's argument is, I think, that this is what they were doing in method proposition 14, which indeed would completely rewrite the history of the prehistory of the calculus. So we have a very learned article in a journal called Sciamus, which can be interpreted as "we know" in Latin. Actually, we don't know. There are only about 10 copies of this journal in existence, I think. And it's written by 3 people, and probably read by 5. The wives of Reviel and Ken might have read it. But anyway, we also advocated it in the press, and the press sort of got the picture. The Eureka page, exclusive. It's just a few lines of scroll Greek text, but new technology has identified the hand of Archimedes, and the results are rewriting history. I'm a great advocate for this program, but I don't actually say that. But one of the things about the press is that they have been very helpful in helping us find the people to do the work. And I think it's probably one of the reasons, if we've been successful, one of the reasons for our success is the name of Archimedes, because scientists are interested in him as well as humanists. The other treatise that is unique to the Archimedes text in the Palimpsest is called the Stomachion. And everyone knew that in some sense it concerned this diagram. This diagram is a square, and it's made up of 14 pieces. But no one knew what Archimedes was doing with this diagram. What about these 14 pieces? And by largely through rereading the manuscript, the Archimedes manuscript with our pseudo-color images, Reviel Netz came to a new thought, which is that perhaps what Archimedes was doing was recombining all those pieces in a way that still made a perfect square. And finding out how many ways you could still make a perfect square with those pieces in that combination. Anyone want to guess the answer? 17,152. There are 17,152 ways in which you can recombine those pieces into a perfect square. How do we know this? We don't know this because we only got the first page in the Palimpsest. The rest of the Stomachion is lost. So we don't know that Archimedes, we had to work it out. So how do we work it out? Well, we get a computer scientist to do it in one room, and in another room we get, and Bill Cutler did it through software. And in another room we got a combinatoricist, a guy called Percy Diaconis, he's the guy who told you that when you flick a coin, it doesn't actually land 50-50. 51% of the time, it's going to land on the side that it was up when you flicked it. So if you've got kids in Little League, remember that. You'll give your kids an advantage. I believe that's important. And they came to the same answer. So this is more than a game. This makes the Stomachion the earliest treatise in Western science in the mathematical branch of combinatorics, which is important if you play poker. It's also important if you design modern computers and how they interact. There we are. 14 pieces, 17,152 solutions. And one of the ugliest photos ever to appear on the front page of the New York Times, because our images might be useful, but they're not pretty. If you were paying attention earlier when I said something very quickly about the fact that this palimpsesting process in this prayer book, it happened to more than the Archimedes text. There were six other books that this happened to. And normally, the palimpsests are quite common, and finding important texts in palimpsests is quite unusual. Some Euripides has been found in a palimpsest. Cicero's Republic exists entirely in palimpsest. But normally palimpsested texts, you can find them elsewhere. I'm not saying they're unimportant. They can be very useful in establishing a textual tradition, but normally not so. But I got this email from Natalie Chernetska, who was working on the non-Archimedes pages in the palimpsest that had never really been looked at. But we decided we wanted to find out who kept Archimedes company in this prayer book. And I got this email. It says, "Dear Will, in the course of further exploration of the non-Archimedes folios, I recently deciphered the text of a Greek orator unknown. Otherwise, I could identify parts of lost speeches by Hyperides." Now, Hyperides is not a household name now, but he was in the 4th century BC. He was a contemporary of Demosthenes, and he wrote 77 treatises. He's one of the 10 canonical orators of antiquity. But unlike Demosthenes, he didn't make the transition from scroll to codex, which happened in the 1st century to the 4th century AD. This is the only Hyperides ever to have been found in a codex. He was discovered in papyrus scrolls in Thebes in 1847 and 1898, but this is a codex, and it's about 1/3 of the entire Hyperides corpus. There are 2 speeches, the most important of which is Hyperides defending himself in Athens after the Battle of Chaeronea. He advocated for resistance against Philip of Macedon and Alexander the Great, which was a bad idea. Alexander the Great beat up Athens, and Hyperides found himself on the wrong side, so he was accused of treason, and here he is defending himself. He talks about some of the great events in Greek history, Salamis, Thermopylae. It's a very eloquent speech, and he got off. Eventually they tracked him down, and they killed him, and they cut out his tongue. But when I get emotional about it, then I like to think that we've given Hyperides his voice back in the 21st century, and that's very exciting. This work has been published, and we move on. And on June the 11th, 2005, I got another email from Nigel, and it says, "Dear Will, excellent news. The hard drive of the photos came safely this week. At first glance suggests there's no more Hyperides, but several leaves of a philosophical text, on one of which I found the name Aristotle clearly enough." Clearly for Nigel isn't really clearly for the rest of us. But it's there in natural light, and it's sort of there in a pseudo-color image, and so I've just highlighted it for you there. With the Archimedes text, it was essentially the work of Nigel Wilson and Reviel Netz, but when it came to the Hyperides text and the Aristotelian text, they were previously unknown, so you didn't even have an edition to work from, as well as images to work from. And they were far more obscure, and it took a whole team of people working on the text collaboratively, which they've been doing since 2005. And a lot of this stuff is done virtually. So here is a forum, and if you're a member of the public, you could have joined the general discussion and And that was the bit of the forum that you saw, and you could argue ad infinitum about the rights and wrongs of Christianity against science. It was very interesting, actually, because it started out as a rather coarse discussion and ended up with the public finding a wonderful balance of whether the guy who'd palimpsested this material had done us a favour or whether he was against science, and the balance was that he'd done us a favour, which was a rather nice conclusion for them to draw, I think. The scholars are working down here. Archimedes news, Hyperides news, Aristotle commentary news. And so they're working in a digitally remote environment, and rather a clunky one. And it's still now difficult to come up with a remote working environment for the scholars that's satisfactory. But nonetheless, you can trace all their work. There's David Whitehead from Queen's University Belfast and Chris Carey from the University College London, working together to try and read the Hyperides text. Here's Nigel Wilson and Bob Sharples from University College London trying to read the Aristotle text. We blew things up on a screen for Nigel to see if that helped him to read them a bit better. And as far as I know, the Aristotle text, which turns out to be, we think, Alexander of Aphrodisias' 3rd century lost commentary on Aristotle's categories. It's the only text I know that's been started from scratch on a wiki. And these are the early days of the wiki. As scholarly interest in the folios got bigger and bigger and bigger, so the emphasis and the need was there to work harder and harder and harder. This is an iron map of the first page taken at the Stanford Linear Accelerator Center. So this is an iron map of the first page of text there, which is on floating bodies in the original Greek that Heiberg missed. And now we can read it. Again, you have to be a nutcase to read it, because, of course, if you take an X-ray, you take images of... The X-rays don't distinguish between the front and the back of the folio. So you've got 4 layers of text to try and decipher. But if you're Raviel Netz and Nigel Wilson, you can do it. We're still discovering new text, sometimes in unexpected places. And then, on the bottom of, after 7 years of working on this manuscript, we finally found out who did it at the bottom of page 1. Just in the bottom here, you can make out the beginnings of a colophon, and it says that this book was written by Johannes Myronas on the 14th of April, 1229. So in the month before the 14th of April, 1229, Johannes Myronas had created this palimpsest, and he'd done it in Jerusalem, because the prayers that he were copying are Jerusalemite texts. 14th of April, 1229 is about 8 weeks after Frederick II, Stupor Mundi, liberated Jerusalem from Muslim control. So this was an environment in which probably Johannes didn't have access to new parchment, so he used old parchment. It was a time of celebration, and he was pleased. And on the 14th of April, 1229, it was Easter Saturday in the Greek Orthodox Church. It was a time for giving gifts, so he'd finished his prayer book and he was giving it to someone. The scholars transcribe their text in Word format, and we have to turn that into TEIP5 compliant XML. Some of you in here know what that means. And we found students at Worcester, Massachusetts, Holy Cross, under the direction of Neil Smith, and at Furman University under the direction of Chris Blackwell, who turned Raviel Netz and Nigel Wilson's text into TEIP5 compliant XML, so it looks like that, and can be transformed into that so that Nigel Wilson can read it and correct it. But ultimately, it's all data. And our data has been managed by Doug Emery, who's an independent consultant working in Baltimore. And that's what the data looks like to him. It's not transcriptions, it's not images, it's just thousands and thousands and thousands of metadata fields. And we consulted with many of you, many in the field, about how to put our metadata together. So some of you might have met Mike and Doug, and thank you for your help. It's now all on the web, and all of it, All the raw data is on the web. The transcriptions for the Hyperides, the Archimedes, 16 different wavebands of light, the processed images, everything. README files, I hope you can read them. And it's all published under a Creative Commons 3.0 copyright, so anyone can take it. It's a commercial copyright. You can even make money out of it if you can try and make money out of Archimedes. And we are working on graphic user interfaces for this data, but very much driven by the owner of the manuscript, who knows an awful lot about data and an awful lot about the internet. We concentrated on getting our raw data right, and we think we have got our raw data right, and and it's out there for anyone to use. All 16 different wavebands together with the transcriptions, both of the Heiberg XML and the Archimedes XML. And there are geographic links so that you can map it to the line, to the images in the book. So what was in 1998 unread, unknown, private in a book, unappreciated and immensely expensive, is now known, legible, published, and available on your desktop computer, if you have a good internet connection. On 2 p.m. on October the 29th, 2008, it was 10 years to the day after the owner bought the book, we put up a PDF of our results on Google Books. So this is method proposition 14, diagram 1. We're still working on our data. The Alexander of Aphrodisias data, the images, we're still processing, and the scholars are still working to transcribe them. And when they're done, we'll put that up on our data set. So this is Tuesday, the 27th of January, 2009, from Marwan Rashad in France. Dear all, it appeared clearly in the last days that the new images on the website are incomparably better than anything we had until now. Contrary to my first impression, it seems somewhat miraculous to now be able to read portions which seemed lost forever. I thus pray for images of this type for the rest of Alexander's commentary. And if you go onto our website, archimedespalimpsest.net.org, and you look at the image bank, you can see that we're still trying to provide them. So the owner is passionate, very clever, very involved in the project, and he has lots of money. And we're immensely, immensely grateful to him. That was us in 1997 before treatment. That's us now. And we're still going on. We're going on to do new things. This is a Syriac palimpsest that we managed to image, and it contains an early Syriac translation of Galen on simple drugs. There are very, very few Syriac medical manuscripts from the 8th, 9th, and 10th century surviving. This is a palimpsest of 210 pages of Syriac medical text that we're now beginning to work on. I briefly want to talk quickly about a project that we're now doing at the Walters, which is to create digital surrogates of all our Islamic manuscripts from start to finish in 2 years from an NEH grant, and we're on our way. Here we are entering data. Here we are imaging the machine from a Stokes imaging machine from Austin, Texas. It allows us to image carefully with great quality at a reasonable production rate. We can take 53,000 images in 2 years. And as with the Archimedes, we're putting up all our data in the raw for free under a Creative Commons copyright. And we're also looking at interfaces for it. So there's our raw data at the digitalwalters.org. For GUIs, for graphic user interfaces, we are using easy commercial applications. So this is a commercial application called Issue, which is a page-turning software that you can just load up your PDFs on. So we load up PDFs of our Islamic manuscripts onto Issue. And I just started a site called Medieval Manuscripts, Digital Surrogates of Medieval Manuscripts on Issue. So if you're in the position of getting a hold of manuscript surrogates that you can leaf through page by page and load up on PDF, please do add them to this site. Because I think in some ways it fulfills some of the promise of the digital revolution. Rather like the World Digital Library, but user-generated, you can have complete surrogates of medieval manuscripts and turn them through the page, and they're not collection-specific. So you can actually merge manuscripts of one institution for another. And you get very good image manipulation, page manipulation. And the metadata standards are very small, and yet they work. Very low, and yet the bar is very low. It's just a PDF. So that's potentially quite fun, I think, for the future. Thank you very much indeed. I'm happy to take questions if people have them. Yes, sir.
Is the liturgical text of any interest? I saw there was a Euclidean forum on the webpage.
It is of some interest. I mean, any 13th century Byzantine manuscript is of some interest. And there is a scholar called Stefano Parenti who's preparing an edition of it. It's very closely related to a Euclidean at Mount Sinai, St. Catherine's, which was written by the scribe Auxentios in 1153 and contains some very unusual Jerusalem prayers. So yes, it is of interest. It's just not unique Archimedes. Yes?
The use of the signaton?
Yeah.
One especially for the language, or all of them?
No, it was for pages that had a lot of staining or a lot of or forgeries on them. So it was for 7 pages, I think. And on pages, if they were particularly important, we might have tried some areas out. But no, it was just for pages where we thought that chemical differences would make a difference when optical differences were probably obscured.
And the 17 hours you said, is that amount of time exposed, or is that data?
We got it down from 17 hours. By the time we finished, it was about 10 hours per page. No, that's the amount of time exposed. But that's because it takes 17 hours for a pinprick to cover all the space on a page. So only a pinprick is exposed at a time for a millisecond. Yes, sir.
Perhaps related to that, how does the manuscript hold up against, UV and everything else? Is there any damage? You have to, is that a consideration?
It's a consideration in every single thing that we did. So when you expose anything to energy of any sort, you're going to degrade it. So yes, we degraded the palimpsest. We didn't keep it in a safe. We used our talents. We undertook incredibly exhaustive tests on what synchrotron radiation would do to parchment before we put the Archimedes Palimpsest in there, and there is no visible damage. We also actually, one of the nightmares that we had was that the beam would stop halfway through, and then you'd just drill a hole in it. So we had all sorts of procedures to immediately stop the beam if there was any problem like that. Yes, sir.
I'm wondering if Mr. B has any other collecting interests.
Great books. Great books. But that's his main collecting interest. He's got a great library. Yes, sir.
What's the status
Gosh. Well, the pages have been imaged, and we're now preparing to... Abigail is now preparing for their long-term survival. And I think that her main concerns are what to do to support really mold-damaged areas and how to encase each individual leaf. We've made the decision not to rebind the manuscript. Yes, sir?
I know you had an exhibition at the Walters of the manuscript shortly after it was sold. Have there been any further plans to do another exhibition now that so much more is known?
Yes, we are planning an exhibition for the fall of 2011. And we're also planning hard copy publications, complete facsimiles of the most legible text we can do together with transcriptions, a book on the project as a whole, and then critical editions on the unique text in the manuscript, the Archimedes Manuscript, the Hyperides Manuscript, and the Alexander of Aphrodisias commentary. So five books. I don't know when the critical editions will come out, but we're still pretty busy on the project in general. Yes, sir?
Is the text that you've uncovered, would you say it's largely complete or 100% complete? Is it a significant fragment?
We only generate images that are good enough for a scholar to put together a text that he is 90% sure of. Because otherwise you can go on forever. So I think that there are plenty of places in the palimpsest where you can't see anything, but where you've found enough context so that a scribe a modern scholar can fill in the gaps. I think that for the Hyperides, I think that we are 99%, we have a 99% complete text. But that doesn't mean that we have a 99% complete viewing of the text on the page. Does that answer your question?
Yes, so if you're an expert, you can construct something that's quite likely filling in the gaps. And
Right. Right, and with Archimedes this is particularly helpful because he had a rather small vocabulary and he was a mathematician, so he was formulaic. So if you're Reviel Netz, you can construct lines out of nothing, which is handy. Yeah. Yes, sir.
Storage requirements for some of the images. Do you know how much?
1.5 terabytes. Each image, 1.5 terabytes for the whole data set, which we're adding to, but it's 1.5 terabytes now. And it's hosted by the Internet Software Consortium, which is great. There are each large image is 240 meg, but there are JPEGs, so don't click on the large image until you know that you want it. Check on the JPEG first. Yes?
Are there any English translations available?
There are English translations available of the Hyperides text in the Zeitschrift für Papyrologie und Epigraphik for the Diondas and the Timandros speeches. There are translations available for Archimedes, Sphere and Cylinder, together with editions of the diagrams. We are still working on translations of the other stuff, but then we're still working on transcriptions of the other stuff. Yes, sir?
To get the manuscript to the superconductor area,
Yeah.
must have been more than nerve-wracking to travel with the only copy, the originals.
We were careful,
I'm sure you were.
but we don't actually discuss how we traveled. Okay, well, yes, sir.
Were these Greek texts all done by the same scribe?
No. They were all written over by the same scribe. Actually, for about 6 pages, he had some help. But they were all basically written over by Johannes Myronas. But the Archimedes texts were originally in a separate book and a separate scribe and a completely separate endeavor from the Hyperides text and the Alexander of Aphrodisias text and the other texts in the book. So you have to imagine that these wonderful, unique texts were in a library in Jerusalem, and that somehow they were all used for recycled parchment at roughly the same time.
Any speculation about what the scribe would have been copied from, and how far removed that might have been from the original?
The Archimedes Scribe, do you mean?
Yeah.
Yeah. Yeah, there is some speculation about that. Archimedes wrote in a particular dialect of Greek called Doric, and this text has traces of that Doric dialect in it. So Nigel Wilson would say that, you know, it's 4 or 5 times removed, not much more than that, which is kind of remarkable. For Hyperides, probably even less. There is no manuscript tradition of Hyperides except this one. So it's a book that was hardly ever copied.